Greetings, pre-calcers. Welcome to the first of many lessons in this pre-calc course. For the last few years, you probably have heard of me, or if this is your first week hearing of me, I'm Mr. Cortez. Throughout the course of the year, if there are any questions that you have about the course or the videos that show up that you have to watch to get the good information on pre-calc, you can email me at ccortez@cuhs.com. Let's kick this right off with pre-calc. All right, so with this first section, dealing with algebraic expressions, mathematical models, and real numbers, all of these objectives here are nice if you want to copy them, but truly this is going to be a bit of an algebra review. And the main two things that are new that you probably have not seen are going to be finding the intersection of two sets and also finding the union of two sets. And that one isn't too bad, so we'll get there. So these are our objectives. If you think they're going to help you keep organized, definitely copy them down. But we'll kick it off with the first example, where we're being asked to evaluate the algebraic expression for the given values of the variables, where we have this expression 3x plus y dividing with x minus 1, and we're being given the information that x is equal to -4 and y is equal to -2. With situations like this, they give us an expression, they give us what the variables are equal to. This phrase will come up quite a bit, but all we're really doing is plugging and chugging. And what does that mean? We have these variables here. We have numbers we can put in place of it, so we really just put them in. So instead of x, we can put in -4. Instead of the y, what do you think we're going to put? Should say that we're adding on 2. And there it is. We see x again. That can be rewritten as -4. -4 subtract 1. And so from here, this looks nice. We just plugged in for the variables with information that was given, but now we have to evaluate a little bit. So I know that 3 is multiplying with -4, so we'll rewrite that to -12. We then add on 2. We then have the -4 minus 1. I keep the negative numbers in parentheses, just makes it easier to work with. That's definitely a good technique you should hold on to. -12 plus 2 we can rewrite as -10. -4, and we're deducting 1. What do you think that's going to get you down here? You should be saying -5. We have a fraction of -10 dividing with -5. Both of these are divisible by 5, so we can rewrite this as a +2. Both terms are negative, so we're allowed to rewrite it accordingly. The next two questions introduce the idea of intersection and union. So what this I means is that we're looking for pretty much numbers that repeat between these two sets. That's what these are called. These are called sets. So when you see these little curly brackets, this is a set. It's pretty much a little house for all of these numbers or data pieces that we're trying to evaluate. So we're looking at these two sets. We're seeing if there are any numbers that repeat between the two. Well, we see that 10 is not seen over here, 12 is not seen over here, 14 is not over here, 16 is not over here. So there's actually no repeating numbers. And so this allows us to say that this is what they call an empty set. So this is the symbol they use for an empty set, where there's just nothing in it. I mean, you could also say something like this, but you wouldn't want to just say that the set is 0, because that's implying that 0 is a number that's repeating, and we know that none of the numbers repeat, so we say that it's what they call an empty set, because there are no repeating values. With the union, although this looks similar, we're now looking for the opportunity to combine sets. So it's as if we take information from the first set, we combine it with information from the second set, we put it all into one nice clean set. So if we look at this, we know that when we're taking the union of these sets, we want to take 10, definitely. We want to take 12, definitely. It doesn't have to be in increasing order or decreasing order. It can kind of be whatever you're up for. We have 14. We have 16. We have 9, 11, 13, 15. So this would be considered the union of these two sets. One thing to look out for is that sometimes you'll have terms repeating. So you might have, let's say, a 7 here and a 7 here. You would only want to write 1 7. So that's something to keep in mind. So only write numbers once. You don't want to be repetitive with it. Say that you have 2 7s. You just want to make sure that if you have a 7, it's only written one time. So that's a key thing to remember. If we flip it to the back, absolute value shows us the distance from some number to 0 on the number line. If we dig deep into this, it's the absolute value of -4 subtracting the absolute value of -8. So I work from the inside out. So work from inside to outside. So way in the middle, I see absolute value of -4 subtracting absolute value of -8. Absolute value of -4 is going to be +4. You've seen this in Algebra 1 and Algebra 2. We're then deducting the absolute value of -8, which is going to be deducting 8. This gets 4 minus 8, so that's -4. But remember, you still have the absolute value on the outside. So if you want to add that in towards the end, that's a good look, because you still want to hold on to it. And then, what do you think? Absolute value of -4. Can that be rewritten? You can say that that's +4. That's your answer. Easy enough. Quick simplifying of algebraic expressions. We see a lot going on here. Again, similar to the previous problem, work from the inside out. So you have 4 minus 3 with brackets around 6 minus parentheses 3y minus 2. Seems like there's a lot going on. But if you look in the brackets, what I am pretty sure we can rewrite is definitely holding on to the 6. But then you're subtracting all of this. So you're subtracting 3y. Think of this as foiling. So this is kind of foiling in disguise from Algebra 2. So 6 minus 3y. You're subtracting -2. So you want to add on 2y. Keep the brackets out. You can actually clean this up a bit. 6 and 2, you can rewrite to 8. It's still deducting -3y. And then if we work out from there, we have this -3 hanging out on the outside. So let's distribute that in. It's -24 plus 9y. And now we'll keep this in brackets because we FOILed it. What am I missing? I worked from the inside out, but what was at the way outside that we need to keep in mind? Quattro, 4. There it is. So let's do this. So we